welcome back to our webinar series on microservices testing. Today, we would have our session on white box testing essentials, right? So we'll deep dive into different kinds of white box testing strategies, how to write good code for white box tests, right? And some of the best approaches towards implementations of these white box strategies. However, most of you would have joined us again from the last session, but for those who couldn't join us last time, I'll do a quick recap of what we did. So I'll move. So in the last session, which was ideally the first session amongst the three of the sessions we have planned, we talked about a test pyramid for our microservices, which has so many layers, if you see, right? From the bottom, you start with linting, and the top two, you go to production testing. So there are different layers. Each layer has its own, value, different sort of tests which are required at each of the layers. And then as you move up, the cost of maintaining these tests grow up, and hence we focus a lot more, or rather I'd say invest a lot more onto lower levels of testing, where we need to, work on white box testing strategies. Then we learned the mantra, which we shared based on our experience, which is shift left. So you basically pull all your testing activities early in the cycle. You improve the turnaround time for your testing. You pull in the feedback cycle a little early, to give feedbacks to the team so that the things are built right. Another important thing we learned was quality must be baked in rather than being poured, which means stop considering testing as a phase, right, which happens at the end of the product build. Rather, you invest a lot more at each step of your product building. You bake in quality at each step, with your shift left testing procedures, right? So you do a lot more of testing at the code level, individual integrations, requirement management, and eventually your builds, right? Now, with this fundamentals, clear with us on what needs to be done for a microservice, right? Now, this session will focus on white box. So let's look at the agenda for today. I'll start with some interesting figures, right? Some numbers which will help us understand a lot more behind, inside microservices adoption and, how some of these tools are being used. Next is popular tools for testing microservices. So we'll hit the Java space today in our sessions and see what tools are available. Most of them you might be aware of already. Then we'll look into white box testing and best approaches across all the different layers that we have talked about: static, units, contracts, integrations. And also we'll deep dive a little in the test doubles, the strategy that we, kind of advocate for building your white box tests. We'll then move to a live code demo on writing automated integration tests. I think it's an area which would be new to quite a few of us on this call. So we have built an in-house microservice on top of Java stack, and we'll showcase writing unit tests and integration tests on that Java microservice. At the end, I'll leave you with some more takeaways from the session and a glimpse of the final session, which will happen next week, Thursday, same time. Let me move to some of the numbers. I like facts, I like data, so I share some numbers based on surveys which have happened of late. The first interesting number is the primary languages used by microservice developers. So you see there are a lot of object-oriented languages being used these days, right? Still, Java being one of the most popular languages which devs use, right? 41% of the teams who participated in this survey have been using Java for building their microservices. Of course, there are other languages like JavaScript, Python, Go, Kotlin, and other languages where your microservices are built. But Java is still one of the most prevalent languages. The next is architecture. So these microservices, they use RESTful architecture for all their communication. Now, RESTful is essentially an HTTP-based client-server model. It basically tells you, makes you create an architecture where you make API calls using an endpoint, authorizing your request with certain headers, and hit a server. The server will evaluate the request, will validate, make sure that the request is right, and processes that information and returns back a response. primarily the data exchange happens in a JSON format. I'm sure most of us are aware of what RESTful architectures are. But of course, there are other architectures like SOAP, which is quite an old one, but still used at some legacy systems. And then there is gRPC, then there's GraphQL, so many architectures. But RESTful being one of the primary architectures which microservices use. The next data is the use of testing tools, right? So we have JUnit as one of the most prevalent tool which helps you write tests for a microservice. Of course, it is quite aligned to the use of language, right? I mean, JUnit is a Java library which you can use to write automated tests in your code. However, apart from JUnit, you'd see tools like JMeter, which is used 29%, by 29% of the companies who've participated in the survey. Then there are JavaScript-based apps which use Mocha. I mean, teams which use Mocha for running, writing their automated tests. And then there are some other tools as well. Like, I mean, if you talk about C#, then there's NUnit, and then there's so many other tools for security, functional and non-functional testing. Right. But the point here being that JUnit is one of the most important libraries for writing tests. Most of us have definitely worked either on JUnit or TestNG in Java space, right? So JUnit 5, which is the latest edition of JUnit, it is quite close. Probably it gives even a few more benefits than TestNG to the developers for writing automated tests. So based on these numbers, what we've done is we've picked up Java as our base for driving these discussions, right? In case there are, if you feel that your microservices are in different languages, probably there are similar tools available in that language as well, which you can use and build your own test strategy. But what we are going to share is more of a standard, right? Or more of a set of strategies or set of tools which are quite prevalent and we've used and we have seen them working. While credit is from the Wuhan University, so some of these surveys were done by the Wuhan University research, which happened, I think, a couple of years back. All right, so now with these numbers, let's move to some of the popular tools for microservices testing. In Java, we are targeting Java, as I said, for the scope of this webinar series. So most of these tools, again, are quite popular. You would all know about them. Spring Boot is one of a framework which helps you build microservices, build Java code. And not only that, Spring Boot gives you a testing library, which allow you to create some test annotations. It provides you an API client to make HTTP calls and all that. So it's there in Spring Boot. JUnit, as all of you know, is a very popular unit testing tool. Mockito is one of a library which helps you create mocks, right? So we'll talk a lot more about this tool when we go deeper into unit and integration testing, right? But it'll help you basically imitate real objects. So the behavior of real objects into predefined fixed objects, which you can use to run your tests. WireMock is essentially a library that will allow you to create, a mock server at runtime. So instead of pointing your test towards the real server, which could, in your case, be any other microservice or a third party, you can mock those behaviors, like different behaviors, different conditions, or rather, I would say, different requests, and you pre-configure some responses based on those requests and associate that with your WireMock server. The moment you point your testing URL to this WireMock server, right, you will test your logic and you assume that the responses from your real server will be exactly what your WireMock is responding. So you can set up WireMock in your code to test your logic by mocking all other behaviors, like behaviors which you don't control. Jacoco, it's a Java-based source code scanner, which will allow you to find out, some metrics predominantly on the code coverage, right? So it tells you what is the, how much of your code source code is covered via unit or integration tests, right? So you can use this tool for just, writing some of these static checks. Test containers, I think it's quite prevalent these days in the Java world. So test containers, they need a Docker daemon to be running in behind, but they provide you on-the-fly containers. So for example, if you want to test a data streaming server, or basically a microservice pushing information to the data streaming server, like a Kafka, you can, rather than having a Kafka setup on your machine, you could just simply create a Kafka container object within the test boundary. So that what that will allow you to do is validate whether your application is pushing data to a data streaming server. And within the scope of the test, you can run this Docker container and you can put it down. Right? So you don't need a setup for running your test with these containers. Next is Pact. Pact is a contract testing tool. Right? It's quite prevalent. It's available in multiple languages. I mean, it supports Java. It's there for JavaScript. It's there for, I believe, C# as well. Right? It's a tool which helps you do validation of contract. And we'll talk a little more about it when we move on. Docker is a containerization tool which helps you create containers out of images. Right? So you can set up your microservices to work across platforms in a Docker environment. Right? So I think Docker is very, very popular these days. And you can run your tests as well in Docker containers, right? So that's where we have used a lot of Dockerization. Rest assured, Java API client you can use to make HTTP calls. Jenkins is a CI/CD tool that, which is, of course, there are other tools like GitLab, like GitHub, Bitbucket, Bamboo, and all. The primary, role that these tools play is for helping you do continuous integration, which means they help you create pipelines where every code check-in can be complemented via tests, which are automatically triggered upon check-in, right? Plus, of course, you can do a lot of scheduling of your tests on tools like Jenkins. Local stack, this is an interesting piece, right? So local stack is a local cloud which is available to you for faster development and testing. So you have some cloud components like, for example, S3 buckets on AWS or SQS on AWS or DynamoDB, right? Or things which basically these real cloud instances. However, to integrate with them, right? Local stack will help you do a development faster by having a local copy of these clouds. So without the need of hitting the real cloud servers, you can test your integration with these cloud servers locally with local stack. So it helps a lot when you are writing integration tests for a microservice based on Java. And SonarQube, it's one of a GUI-based dashboard-driven tool, which will help you create some visualizations on, reports like code coverages, non-functional parameters like maintainability of your code, scalability of your code, vulnerabilities in your code, etc. It also gives you some static issues like, where are the code smells, what are the potential bugs this code might have, and stuff like that. So these are so many tools like in the space of Java, which we have used of late with microservices. And you can start looking into these tools while building your strategy as well. From here, we move on to white box testing. So now we know what tools are. Now we know what white box testing should do. Let's just visit what white box testing actually is. And we've read all of this in our textbooks long back, right? But this is a time where we refresh and kind of form a common understanding on white box, right? So white box tests basically are directly consuming your source code. So these tests reside in the same repo as your microservice, and they have access to the classes, the methods, which are basically the source code. So rather than hitting an API or consuming the application from a user perspective, you have your test sitting very, very close to the source code to validate variety of things. Like you would validate logic, basically how your individual logics are built in your source code, your integration points, and the structure, like how the API requests and responses should be created. So all these sort of validations can be done at the white box testing level itself. These white box tests can be executed during the build phase, which means while your application is being compiled and built, even before any deployment is happening, these tests could run, right? Which means they are very, very close in the pipeline, the earliest of the stage. So your feedback is very, very early. I mean, in your PR, the moment you raise a PR, your white box test would run and give you a feedback. And because they are directly accessing code, the turnaround time, the TAT, is very, very fast. So these tests are typically taking milliseconds to run individually, right? So if you put these tests in parallel, your entire white box testing can happen in seconds, right? I mean, even if it has many tests. So that's one of the biggest benefit of white box testing. It helps you identify problematic components. So it'll find out where exactly the problem lies in the code, right? the errors that your code is generating, and will help you adhere to certain code qualities. So it'll find out whether your code is following certain coding standards, some coding guidelines or not. Under white box testing, we have 4 different kinds of standard practices, right? One is static checks, unit, contract, and integration, right? Now let's look at each one of them individually and see what are the best practices on these white box testing approaches. Static checks. Static check means that your code need not be executed for running these checks. So you provide a plugin or a library in your code, right, which can scan your code in the state where it is without even running your commands, right? And it'll just read the code. It'll try to match the code against certain rules which are predefined, and will tell you that whether your code is following certain guidelines or not. So that is what static check means, right? Now let's look at one of the major strategy under static check, which is linting. So linter libraries are basically those libraries which will scan your source code for quality and standards, right? It means that you add certain library which will help you figure out if there are any potential code smells in your code. For example, you have created a loop, but that is not ending, or it might end up creating an infinite loop, or there's a dead code in your somewhere in your class, or there are variables which are unused. So some of these coding guidelines or coding principles, these linting would help you streamline them across your team. So there are multiple devs, they have their own styles of writing code, but having these linting would kind of channelize all of them in a single direction, right? So that helps keep the coding standard maintained over a period of time. You can enable these linting rules as part of your PRs, right? And on the CI/CD pipeline. So one of the earliest job in your pipeline could be verify linting is working fine, right? So it'll run those scanners. Those scanners would run basically, and it'll report whether there are errors in the code or not. If so, your CI/CD pipeline would show a failed job. That means you're not allowed to move your PR ahead, right? And that essentially reflects the idea of building the right things upfront, right? There are tools like Checkstyle, PMD, SonarQube, which will help you, do this kind of linting. So these Checkstyle, PMD are free and open source tools. You can simply go down and install them as plugins or use their dependencies in your code. And SonarQube is more of a UI-based tool, which you'll have, I think it has an enterprise version as well. So you need to set it up for your projects, multiple microservices, and it'll help you visualize all these linting issues, all these static issues on a single dashboard. With static checks, you can implement something called as code coverage, right? So code coverage ideally is the amount of source code which is covered via your unit tests, right? Now, when we say code coverage targets, one of the good engineering practice is to define a threshold for how much of your source code should be tested, right? Which means I can have a target of 90%, which essentially reflects that I would have unit tests which cover 90% of my code paths, right? Now, these targets would help you achieve higher test coverage over a period of time, right? So you basically have all your logics, all your branches in your code covered, right? And if you're meeting your code coverage targets, right, that will help team come to a standard of what coverage we need. You can use some plugins and tools to capture these code coverage, right? Like as I said, Jacoco is one of the tools which will run in a Java code. And you can use tools like SonarQube to visualize those reports. So Jacoco will find out these reports and put it to your console. But if you want to, make it big, share it with the entire team, have a dashboard on it, use a tool like SonarQube, which will help you publish these reports. Enable quality gates at PR level. So that's one of the very important aspects of static checks, or for that matter, any sort of testing, is that we help devs find out these issues at the PR level itself, right? That means if any of these code coverage target or any of the linting rules are not met, your quality gate, which is basically a concept that, which defines certain rules, if they are met, your quality gate opens and you are ready, you can take your PR to the next level, which is merge. If the quality gate doesn't, is not satisfied, your PR cannot be merged. You need to first fix the issues, and only then your PR will be, will be allowed to merge. So you can enable certain quality gates. So now at the bottom, I've added a couple of screenshots. One of them says that your quality gate has passed because your parameters are all satisfied. You don't have a potential bug in the code. You have less number of code smells than you have expected. Your code coverage is 100%. You don't have a security hotspot. You don't have a vulnerability. For that matter, you don't have even a duplication, which means you have not repeated your code in this PR. However, on the right, the quality gate failed means your target code coverage was 80%. But in the new PR that have been raised, there is new source code addition, but there's no new test. So your code coverage is 0%, right? Which is an indication right away that we are not adding enough tests at the root level, right? And that should stop my PR from going ahead. The devs need to get this feedback that, hey, I have missed writing some tests. Go back, add the test, make sure that the coverage is good. It meets the target, the threshold, and only then you go ahead. Similarly, for any other sort of these, parameters like bugs or vulnerabilities. So these quality gates, you can try and implement them at your PR level. SonarQube will definitely help you in doing that. Or there could be other solutions as well, which you can figure out based on your ecosystem. But the concept remains that you have to stop bad code getting introduced in the master. That's the whole principle here. Moving on to unit tests. So unit tests, basically first understand what a system is, right? A system or a microservice is a combination of multiple blocks, right? If you see on the right side of the screen, there's so many blocks basically are different functionalities, I would say, or within the code, there are different classes, different methods, which are implementing your microservice. What we need to do is find out such individual units which can be tested. These units are primarily the smallest part of your application, which has its own logic, which can be validated, tested against different conditions. If your unit is meeting the expectations, if all the tests are passing, probably you do this testing for all your units, right? Which essentially will tell you that your code quality, the implementation is not wrong, right? So it avoids any of those logical errors which otherwise you would find, at a staging or a QA environment level. So we need to invest heavily on finding those units and writing some tests. For unit test best practices, start testing each branch in your source code. That means you cover up all the possible test data sets, your boundary validations. We've read about those boundary value analysis, your equivalent classes and all that. Those kind of testing concepts can be used at the unit layer, right? And you can test for all possible null checks and inputs. Probably for all other exceptions as well, which your code can, generate. The idea here is to find out whether my application is not failing when it is not supposed to, or whenever it is failing, the failures are handled gracefully, right? Now, one of the most important aspect of testing units is mocking. So you have to, mock all your external dependencies because a unit has to be tested in isolation to each of the other unit in the system, right? A unit may be requiring, other components like a database or a queue, or a webhook, right? Which basically are triggered whenever events happen. But these components, if you have to test your logic in a unit, you should be mocking these external dependencies so that you can validate whether the logic you've implemented works in all conditions, right? Focus on a class. So when you are writing these tests, your contexts have to be independent, which means you have to focus on a class. So, take any example of any object-oriented language like Java, you would have different classes, right? Where each class have a single responsibility. So your unit test needs to focus on individual classes and their methods to create the test suites, right? And you need to ensure that each of your unit tests is independent of the other unit tests. So your test interactions should not affect each other, right? And that is where this concept of mocking would help. So because you're not changing the state of the system, each unit can be tested individually, from the same state. Now let's talk about a simple example, right? There's a class in your code called calculator, right? I just wanted to explain this with a simple code. Of course, at the end, when we have a code demo with a microservice, we'll show how a unit test for a real microservice can be. But from a concept perspective, let's see how this method works. There's a method which takes an array for summing up numbers. It has its own logic, right? And it returns the summation of all the numbers which were provided to it. Now, if you have to write unit tests, you have to find out that what are these individual units where the logics have been implemented and what could be the possible inputs which this method should accept. So you can write, I have written a couple of unit tests here. One of them is testing the logic with a negative input and another one is testing it with a positive input. What does that mean, right? This means that what we are doing is just creating an object of the class which is under focus for testing. We are not worried about any other class in the system right now. And we're asserting that given different inputs, different possible combination of inputs to my method is returning the expected output. So you do this testing for each individual method within a class, and this will give you a lot more of coverage and confidence that all my units, all my implementations have been done right. Right? So this is what unit testing would mean. Now let's move to the next layer of white box testing, which is contract testing. All right. Now, before getting into contract testing, let's first understand what a contract is. Right? For a microservices context, a contract is essentially, API contract between two parties, at least. There could be more, but two parties wherein information exchange is required. Right? For example, there's one service called user service, and there's another called sign up service. I think I took this example last time around as well. So your sign up service will have a contract with the user service that whenever I make an API call get user service has a responsibility of validating whether this email ID already exists in the user service database or not. If it does, it returns this, this information back to the sign up service that, oh, this user already exists, right? And sign up service can have a logic based on this response. If the response is the user is available, so the sign up service will give an error that you can't create another user with the same email ID because it already exists. Or in the other case, user service returns, oh, we don't know about this user. Sign up service can go to the positive flow. It will allow the sign up. So here in this case, you have one service, which is user service, which is actually the producer of the information, the provider of the information. And then the sign up service is the consumer of the information, right? So a contract is essentially a group of interactions, the request response interactions between this consumer and a producer. Based on this contract, the consumers will implement their own logic, right? What if I request this? If I request X to the producer, right? If I get an X1, I'll respond it like that. If I get an X2, I'll build my logic according to that. If I get X3, so on. So based on different responses, consumers will build their own logic. So that is what an API contract is. However, while you move, in time and there's evolution of these API contracts, right? There could be multiple consumers to a producer, right? Same APIs can be used in different ways by different consumers, right? Which means there's a need of maintaining the versions of these contracts and this compatibility at all points in time. Because the moment an API contract is broken, your consumers will start failing because then they're not getting the value they expect from a producer and their entire logic will not be executed or will basically have a bugs, right? So to prevent, these contract breaches, right, we come up with this concept of contract testing, which is quite prevalent already, at least in the microservices architecture space. With respect to contract testing, so we test these contracts. So how do we do it? We maintain a single source of truth for these API contracts, right? Now, as I said, there could be multiple versions of these API contracts over a period of time. You need to have a single source because, your contract might change at one place. And if you are maintaining multiple, copies of it, so some consumer could continue using the older version of contract and they'll start breaking probably directly on production, and it has a customer impact. So you don't, of course, want that. So contract testing would mean that you need to have some tools which creates a API contract and puts it as a single source of truth, For example, Swagger. So Swagger is a tool which will help you create your API documentation based on the code itself. So you don't need to manually write API documentation. Based on how the code is implemented, your Swagger tool, based on the protocol called Open API, it will create a Swagger documentation, and it will be hosted to a location where everybody can access. So that Swagger documentation becomes your contract. Now, every time there's a change in the code, a new Swagger would be created and it will start reflecting. So all consumers would start knowing that, okay, this is the latest contract, right? For contract testing, you can use open source tools like Swagger Mock Validator or Pact. So Swagger Mock Validator is one of the JavaScript node packages. Okay, this works in a way where you create these interactions between consumer and producer or provider, and you validate them against the Swagger spec itself. So that's why the name Swagger Mock Validator, right? So the mock or the contract file on the consumer side will be validated against the Swagger spec. So if the interaction which is recorded by the consumer on their side matches the specification on the Swagger, then your contract is kind of intact and you are good with your contract testing. What if there's a change in the code? It will start reflecting on a Swagger, and your Swagger spec will not match your interaction on the consumer side, and your test would break. So you will know that your contracts are broken at this point in time itself, even before you go live. Pact is another tool which is very popular. The way Pact works is a little different, right? In Pact, you create certain interactions by mocking your providers or your producers. Whenever your provider is available, right? Eventually, the real provider, the real service is available. You run those interactions against those real providers. So you match your interactions which were captured against the mock, and the mock were all, of course, created against an API contract. Now, post-deployment, have the producer, stayed or adhered to that contract. That can be validated by running your interactions against the real server. So at that point in time, if the implementation differs from the contract, your contract test will find it. Right? So this is how Pact would work. I really recommend go back and read through Pact tool, which is there's a lot of language support for Pact, plus the CI/CD integration for Pact is also quite sorted. Now, how to bring more value in contract testing? It has to be consumer driven, right? As I said, one producer can have multiple consumers. So, a change made on the producer side may not impact all consumers, right? But what if the contract test for all the consumers starts failing, right? One of the consumers will not even be required to make a change because the change made on the producer side doesn't impact them at all. So that is why we say that contract testing has to be consumer driven. Each consumer creates the interaction based on what they expect from the producer, right? And then they run the test, which gives the provider a free hand to add more fields which are not impacting this consumer and still stay relevant. And the second important aspect is providers in this case can do backward compatible changes. So let's say there's a change in the schema of an API response. One of the object has been converted from a string to an object having metadata information with it. Now, one of the consumers is expecting a string value always, right? But the moment it changes to object, your contract would fail. Rather, what you can do is create another object, continue to support that existing string value, let your consumer know that, hey, we have to move to this new version of the contract. They start consuming the new object, and then eventually they let go of the string type of value. So this backward compatibility is also important with regards to contract testing, right? Next important aspect of contract testing is validation on the pipelines, right? So contract testing should be done on both consumer side and provider side. The consumers, their pipeline should fail when they are expecting, something which is not provided by the producer. Let's say there was a typo in the field that they're expecting. Let's say instead of test, they wrote TEST. Instead of that, they wrote TAST. Now this TAST key is not found on the Swagger spec or on the provider side. So consumer test would fail. It will tell you, hey, this field is not available. And you get to know, oh, I was expecting something wrong, right? So your consumer pipeline need to have these contract validations to make sure that you're not expecting something which provider doesn't really give. On the other side, the providers, they must have these same contract validations on their side because they should be blocked on deploying a breaking change. What if they add a new field without informing the consumer? Or I would say remove a field which the consumer were using till this point in time, but they have made a change, they have added a new, renamed that field. Consumer doesn't really know about it. So the moment they run their PR on their side, the providers, they will know, oh, there's one consumer who will break if we make this change. So they are informed upfront about this contract breach, and they can they can do multiple things. One, maybe make this backward compatible, or if this is a change which has to happen without the need of, or without the need of making it backward compatible, communicate this to the consumer that we are bringing a change, let them update their contract tests, and then do this change, right? So there are multiple ways of handling this, right? Again, it is dependent on how your teams are structured and how the contract test validation is happening. But the primary principle here is run your contract test in both consumers and providers pipeline. All right. So with that, the contract testing best practices are also, we've talked about that. From here, we'll move to the integration test layer, and I'll pass it on to Preeti to take it over.
Yeah, thanks, Anshu.
Yeah, I'll make you the host, Preeti.
Sure, thank you.
Yes, you can go ahead.
Go ahead, right? Okay, let me start my video. All right, hello everyone. I'll share my screen now. Let me know if you're not being able to see my screen. Just give me a minute. All right. 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 So I hope you are able to see my screen, right? So let's look into the integration test best practices, the what's of integration test, the whys of integration test, and what are the best practices associated with it. So, right. So what we have seen so far is about why do we need unit testing and what are the best practices associated with it, right? And why do we need contract testing and what are the best practices associated with it? What happens is we have from experiences and from the teams that we have worked with, it often finds that with good unit test and the contract test, there's still a confidence the team looks for to confirm whether your service works as expected. If a consumer is going to what the capabilities that your microservices has built is working from the consumer and perfectly and all the expectations are being met. So to gain this confidence, additional confidence, and to move into a CI/CD pipeline, what teams also add to it is the integration test. That is where the integration test. So these integration tests helps you to get these additional confidence from a consumer angle, whether your microservice is the microservice that you have built is meeting the expectations, all the capabilities that you have built and all the features that you have built in are working as expected when everything is being stitched together. So with this, right, the integration test actually gives you these additional confidence. So now let's look into what are the best practices that we have with integration tests, right? So the first is we are now looking into the broad integration test category. These different categories that we're going to speak about are being influenced from the Martin Flower testing uh, pages that Martin Flower published. And I would say, after the sessions, please go back and read those conceptuals. Those were actually being published a decade ago, but still holds good for the microservices testing strategies when you want to build in, right? And for the integration test. So what we're talking about is these broad integration tests, and what they actually tend to do is they tend to, let's say for these blocks, nothing but, represents the microservice in whole and the different flows that a request flows from one component to another component to give the expectations or the capabilities that is being built in. So now with these broad integration tests, it gives you the confidence whether are we meeting the capabilities and the expectations from a consumer angle, right? So this actually tends to end your microservice as a whole from the user angle. So this is where these broad integration test becomes effective, gives you this additional confidence. But what happens with time, right? What we have seen, the challenges that these broad integration tests brings in is these broad integration tests expects the entire microservice to be available. That means almost all the components are needs to be active. That is where a lot of stubbing and the mocking techniques are being used. For example, if there is an external dependencies which you have within your microservices, and we use a lot of stubs there, right? You could use a wire mock server or a mock server there. If we are using cloud services like AWS, DynamoDB, or Redis Cache, or if you're using SQS, right? So in those cases, we spin up these services using test containers or other Docker means, right, to make these available for the service and to see that your user journeys are being met as expected. So with these external dependencies being made available, how they are going to be available in a staging environment or any real environment, the entire application context becomes heavy for these tests, and hence also you will see that these tests becomes a little complex and time consuming with time. So let's say if you have n number of tests being added at a broad integration test which test your entire service from end to end test. The first is these tests are going to consume time over the given duration, where you keep adding capabilities to your microservice. The second challenge that these tests brings in, they are very heavy in terms of the lines of code and the complexities, because we're trying to test the entire microservice end to end. There's a lot of assertions and a lot of angles that needs to be tested. So that brings in the additional complexities for these tests. The maintenance also increases here for these tests, and with time we also have seen that these tests becomes a little flaky, right? So now what happens is, to overcome these challenges that these broad integration test brings in, and only to take out the best confidence that these broad integration tests provides. So we divide these broad integration tests next into a narrow integration test. So that means when we work into a integration testing strategy, we writes in combinations of broad integration test and then the narrow integration test, where your broad integration test only focuses around the positive flows and the entire capability your microservices providing from an end customer angle. The narrow integration test focuses around testing within small test boundaries, right? Just like the diagram that is being showing, that is we're considering only these three modules that we are testing, where the request is being passed on from the first module into this block and then into this block, right? So with this in place, we can test a lot of negative scenarios, a lot of edge cases, a lot of other different combinations of tests could be added, and everything which is outside your test boundaries, we try to mock those dependencies using mock it or easy mock. That means we mock those objects, right? With this, what happens is, with these narrow test boundaries, these tests becomes quite simple in nature. The execution time is very small. These tests runs very fast when compared to broad integration test. And since again the boundaries are quite narrowed down, these tests are more resilient when compared to the broad integration test. So, and what we have seen is, when you identify these narrow integration tests and test boundaries and write good test around within these, right? So these tests would provide you around the 80% confidence and the coverage, and the additional 20% confidence and coverage you could get from your broad integration test, where you only focusing about the positive test, and where only a limited or a very few tests have been added based on the critical flows that your service is being provided. The other benefits your narrow integration test also provides is, let's say if you have implemented a feature flags, right? So you could verify your in narrow integration test, what happens when your feature flag is being turned off? Is it, these modules are behaving as expected when stitched together? Also, if your feature flag is turned on, these modules provides you the right results. So that's an additional advantage that you get. So very basic example of these narrow integration tests could be, let's say you have you have integrated with DynamoDB, and you have a write and read operations, right? Now, instead of relying on broad integration test to test all the right boundary test for your repository layer, what you could do is we could actually write more concentrated test for the repository layer here in the narrow IDs, where it could verify all the different combinations of read and write operations that is being doing, in case if there's an additional logic and atomic operations are in place to confirm that the transaction is consistent. That could also be verified with the narrow integration test, where the application context is smaller, and it's only brings up only the application context which is needed for these tests. So that's an added advantage for these narrow integration tests, right? Also, these narrow integration tests, let's say if your uh, external clients are within the test boundaries, and we use stubs to verify what your microservice is being sending out to these stubs, and only when the expectations are met and the right headers, let's say the right headers or the right request bodies or patch bodies are being sent, that is where you tune your stubs to respond back with the right responses, right? So you could actually do a lot of so that is where it helps you to verify everything what your microservice is sending out, and verifying are you able to process what is being received from your external clients as per the expectations within these narrow integration test boundaries. So now moving on to the next part, right? How does the contract test actually helps us? So with as what we have been discussing, and with these broad integration test and narrow integration test, we use a lot of stubs for external clients, right? To ensure that our stubs are in sync with what are the contracts that is or with the contracts that has been agreed before. The contract is complements here, right? So even if we question that, how do I get a confidence if I'm using a lot of stubbing and I am creating all the requests, or I'm creating the responses that is being need to be sent out by these stubs. So what if it fails in when we're deploying to the staging environment or into a QA environment? So all we need to ensure that a right contract test have been written, and the request and responses which are being constructed by these contract tests are also in sync with how you are preparing your request and responses for these stubs. So that is where you could actually rely and see that your contract test and your integration test are in sync and uses the similar response structures and the request structures. So with this strategy, right, where you divide your integration test into broad integration test and narrow integration test, and complements these with the right contract test, there are key factors that you can also associate with these integration tests, right? So let's look into these key factors. One is run these integration tests as part of your CI/CD pipeline. So with this, what will happen is it'll give you an early confidence, and as soon as a developer changes the code in its PR and pushes the changes to its branch and raises a PR, and if these integration tests are also running as part of the PR build, you will get to know then and there itself if the new change has broken anything in the existing expectations, and if the new expectations or the new capabilities are working as fine, and all these integrations are, it's still intact. So that is the benefits that you get when you run these integration tests as part of the build pipeline and the PR process, right? uh, Moving on to the next is keep these tests in the same source repo. So what happens is we're talking about running these integration tests as part of your CI/CD pipeline. So if you actually so if you actually put these integration tests within the same repo as part of your source code, there are many test library supports are into the market, where you can spin up your microservice within your local from your test itself and within your CI/CD pipeline. For example, if you're using a Spring Boot, so Spring Boot has a very good support with Spring Boot test annotation, where you can spin up the entire microservice from your test and verify whether it's working as expected or not. But what it requires your integration test also lies in the same repo, and you can use and you can run these tests there. So that's an additional advantage that you get while keeping your test within the same repo. The other advantage that you get is let's say you could, if you have integrated Jacoco, as what we have seen in our static checks, right? If you have a Jacoco tool API library integrated in your project, you'll be able to also fetch your what is your integration test coverage, and based on that you'll be able to see if there are any other areas where the new integration test needs to be added, or something which is being missed out. You can add those integration tests later. So these are some of the advantages that you get when you keep your integration test in the same repo as in your with your source code. So moving on to the next factor, just give me a minute. Right. So make use of effective test slices. So this term effective test slices is also introduced by the Spring Boot testing strategies, right? And which is quite similar to what we were discussing for the narrow integration test. And what it talks about is as your microservices consist of many small components, instead of only relying to test all the entire microservice as a whole, we could start focusing on these small components to see that if these components are working as expected or within the small boundaries of these test components, and that will give you additional more enough confidence, and you could actually limit the entire broad integration test and keep it very minimal there. So what happens with these test slices is you'll write the focused controller test to verify if your controller is working as expected or not, where, and if the, let's say if whatever the user request is being sent, are we sending out the right responses to the users or not? If the request is not correct, or if the headers is being missed out, right? Are we sending the right exceptions to the user or not? And is the serialization or deserialization is working correctly, right? So so that is the advantage that you get when you only write the focused controller test. And for that, the controller test, you don't need entire microservice to be available, isn't it? All you need is just the web server where it has the and where you can spin up just the controller and just post a request to it and see that is it behaving as expected or not. The other example could be your repository layers that we were discussing. You could just have the focus test around your DynamoDB repository layer, or just your caching repository. Or let's say if you have an SQS, you could have a focused integration test around your SQS alone. The next area could be, let's say if your microservice is both asynchronous service, has a sync flow and has a async processing involved, right? So let's say where you receive a request from a controller, it stores information in a DB, and then also passes on this passes the attributes into the queue, and from queue you have a consumers where it reads the message from the queue, and there are workflows designed to process this request in an asynchronous manner. So to test this microservice as a whole, it's going to be very complex, and your test might, if you add a lot of tests to your broad IDs again, it will be very time consuming, and maintenance could be also a factor there. So what you could do is you can use again test slices. You could have your sync flow boundaries decided, where you can have just a test for sync flows, and then within the sync flow, whatever the different workflows you have, you can have just a concentrated test around your workflows. So that's an advantage that you get when you use effective test slices strategy, right? Uh, Moving on to the next is effective testable strategy. So with microservices, as we want to test an entire microservice independent of any other external dependencies, what we use is we use a lot of testable strategies. Either, if we have to spin up a external dependency, external cloud dependency, or we have an external API dependency, right? So we use a lot of testable strategy here. And as we know, there are there are four types of it. One is fakes, one is stubs, one is mocking and spy. So based on but there's a slight differences when it comes to each of it, and if you understand its slight differences, you will be able to use them effectively, and can actually bring you a right confidence in your integration test, would be more resilient and makes your integration test much faster. So using the right test double for your integration test actually is the key here that we'll discuss more into the next slide of what's the right testable strategy could be. Um, right, so moving on to the next best practices, keep your test independent. What we have often seen that if these integration tests, right, if let's say if you are creating an entity, it is important that you create that entity within your test and then you actually clear the state afterwards. And let's say if you are calling a stub within your test, it is important that you structure the request and response as part of your test, and something which is not available later to the subsequent test. So that makes your test more independent in nature and ensures that any state or any entity that you update as part of one test, it doesn't affects your second test workflow or any verifications that you have added, because that becomes a lot of that becomes, when your tests are not independent, it is the reason why your test becomes flaky. And hence it is quite important that you keep your test independent all the time, while you're designing your integration test. And something that we'll see also in the demo, how to keep these integration tests independent of each other, right? So these are some of the integration test best practices that we had. There are few others also, possibly just want to touch upon briefly about it but not go in detail. The one is keep your execution time always in check, right? For broad integration test, have these guidelines where your single broad integration test does not exceed the SLA which you are committing to your customers, right? And actually, since you're not really calling in external dependencies, your broad integration test must be much faster. You can actually keep an eye on how long your broad integration tests are running and see that it does not exceeds beyond the SLAs that you have already been committed to it. Let's say if it's SLA is 3 seconds, ensure that your broad integration test always completes within a 2 seconds or even a second. When it comes to narrow integration test, you can always publish a guideline that narrow integration test does not uh, takes more than second, or actually should be taking milliseconds for that matter, because your narrow integration test lies between somewhere between your unit test and your broad integration test. So that means these tests are smaller in terms of how you write unit test, and but not as fast as unit test. They're just slightly slower but much faster than when you compare to the broad integration test, right? So keeping these guidelines for your broad integration test and narrow integration test will help you keeping your execution times always in check. The other important factor would be, keep your resource utilization optimal when you're running your test in your build agents, right? Since we are using a lot of testable strategies where you're starting a mock server and where you're going to use a fake like local stack or test containers that we were seeing in the tooling stack, right? So what happens is when you are, you know, creating these servers or test containers or initiating these dockers from your test, it is important that you destroy them also and keep an account of how many of such instances are being created, because your build agent is limited in terms of resources, and the number of resources that you create, along with that, if you do an extensive logging, that is going to affect a lot of your test execution time. So if you want to spin your execution time and make it more faster, then keep your resource utilization always optimal in your build agents. And that also holds to the logging that we are doing. So these are few of the key best practices when we talks about integration tests and how to run these tests optimally as part of a CI/CD pipeline. So moving on to the next slide, right? All right. So let's quickly look into what is the testable strategies and the best practices around it. So what we have seen in the last slide and in the very first sessions, we have talked about the different the different testables which are available. But now let's look into it, what each different testables are and what are the best practices associated with it. The first is Mockito. We have seen, right, in unit tests, we use a lot of mocking, and few of the best tools that are available in the market are for Java projects when you're using JUnit framework is Mockito or the Easy Mocks. So what Mockito or Easy Mocks helps you to mock the objects. That means if you're unit testing your class, anything, any external dependency for your class is being mocked. And we don't make any network calls in your unit test. See that when you're designing your unit test, you are not making any network calls and everything, because any network call is actually leads to an external dependency. So if you're making an network call in your unit test, that means you are actually spinning your external dependency as part of your test, which is not the best practice for your unit test here. So see that you mocked all your external dependencies and there are no network calls involved. So that makes these tests very, very fast. And just in terms of in milliseconds, you can run quite a good number of tests. And even if you have thousands or 3,000 or 4,000, 5K tests, you would be able to run these tests in a matter of seconds. Moving to the next testable, what we have is the stubs. So there is a slight difference when we talk about the mocks and the stubs, right? The mocks is where you mock an object and where your external dependencies lies outside your test boundaries. Now what happens is with stubs is where these are used where you are making a call to an external client, and this falls within your test boundaries, and something you would often see in your narrow integration test or a broad integration test, where within the component or within the two components that you have, which you have bounded for your test boundary for a narrow ITGR, you're making an external call to a client. And since the client, we say that we should be isolating our microservice when we are testing it, so we use stubs there where where your test actually makes your application to make a call to your external dependency, but we only uh, you know we only send the response back if we are sending the right headers, if the right request, or the in terms of put, post, or patch, the expected request body is being received, and you fine tune your stuff to send a response back with the right status. So so this is where you use your stubs to mock external dependencies, and where your these external API calls actually, or the external clients lies within your test boundaries, right? Uh, Moving on to the next test double is our spy. So uh, so there's a slight difference, right? When so spy objects are being provided by, even if you're using Spring Boot, you could use a spy bean, or if you're using JUnit, right, or Mockito, you can also use create spy objects from it. But what happens with the spy objects, it's that it lets you spin the object as in your application context as how it is going to be made available when your application is running. So that means you're not mocking an object, but it will keep track of all the interactions that you make with the spy object here, and what method are, if you have, how many times you have called the methods which are associated with this object, what arguments have you called this spy object, right? So it keeps track of this behavior and helps you verify a lot of things. For example, you are posting a message to a webhook, which is part of your narrow integration test boundary, but to verify this, whether the right message is being sent out to the webhook or not, it's quite a quite complex in terms of where that something that means you have to make a test webhook also enabled, and need to create a consumer and see that what message is being received. So instead of taking this route, what we use here is the spy objects, and the class which is responsible for publishing a message to the webhook. You spy that class, you create a spy object on that class, and then you can verify all the interactions and what with what payload are you publishing this message out. So everything could be verified there and helps you gain that right confidence. The other example could be an emailing service that you want to verify, right? So that is where the spy object, the spice becomes quite a handy here. Moving on to the next part is fakes. So fakes, you use them when you have your infra dependencies part of your test boundaries. So this is something quite common when you're doing a narrow integration test, or in terms of your broad integration test, which is for unit test you mock all your external dependencies there. So for example, fakes are the for example of the fakes could be the local stack, where for broad integration test you want to spin the AWS cloud services, how you're going to spin, how do you going to interact in the real environments. You can use local stack, but whereas you can also use in-memory objects where you have good library support for DynamoDB and other DBs, right? For narrow ITs, I would say, go for in-memory support where you don't make any network calls, makes your narrow integration test faster. Along with that, if you don't have very complex read and write logics or scanning logic for your DB repositories, I think the in-memory DBs also would be a better choice there. So see, possibly you might have to see how what fakes that you want to use, either the real simulators or the local stack or the Docker image that is being provided, or you could go for in-memory support. So that is with it. Moving on to few of the best practices associated, maybe just to run quickly here. See that you're these, when you are creating your objects or stubs or fakes or your test stub or any of these steps testables, these are independent. It does not affect the test execution. So quite important that you initialize these testables from your test, and so that it is not known to your other test, and you do the very focused verification which could be uniquely identified by the test, right? Because if you keep your stubs or spice quite generic, it might can result in a flakiness in your test. So it's quite important that you keep these stubs independent, these testables independent, and see that does not affect your other test execution, right? This is something that we were also verifying, right? I was mentioning just earlier that uh, the other important is that when you're verifying the behavior of your stubs is being called correctly or the spice being called correctly, right? See that this behavior is uniquely identified by your test, and that can only happen when you initialize them within your test itself. So that gives you an additional confidence and ensure that your tests are not being flaky when you verify these behaviors. Uh, the similar best practice would be keep your testables small and focused, so only initialize or uh, only initialize what is needed by your test, and something which is not needed by your test, don't make it available for your test in that case. So that will keep your resource utilization also optimal, and make your test execution faster in the build pipeline. So it's quite important that you keep these testables small and focused. uh, this is something very common issue that we have seen in my experience. When you are using stubs or when you're using fakes where you need to do a port initialization. So if you're using static port initializations, often you'll see that you'll get these errors where it say that the port has already been used because you're trying to initialize the servers again on the same port. So to avoid, so that is where it becomes an anti-pattern, and to ensure that you are able to initialize these testables as expected, you have to keep these initialization closer to your test and make the uh, uh, port mapping also closer to your test context, so that when each test context is different, it does not interferes with the others, right? We'll see that into the in the code demo. How do we keep these allocations closer to the test context that does not affect the other test executions? Moving on to the next is quite often that we have seen that we also say that clear your state of your testable. So let's say if you're doing any verification, uh, it's a good practice that that you do after each you clear the state of your mocks or spy objects, or even for the wire mock server if you're using, or mock server you're using, see that you clear the states of the request that has been received, so that when you do the verifications next, it becomes quite handy. It does not have to search a lot from the behavior that you're expecting it to be. So I would say clearing the state does not ensure that your tests are going to be independent, but yes, it does helps in the faster test execution. So keep this clear your state after your each test execution for the test doubles. So these are few, so this is how you could uh, create an effective testable strategy, identifying which testable to use in which scenario, and few of the best practices associated with it. So moving on to the next. So let's look into the sample microservice that we have created, right, for the code demo. What we have done as part of this is so we've created a sample employee service which has uh, two API, two resources available. One is create employee, one is get employee. As part of a create employee, what you could do is we pass a post request to a controller, and from controller it sends the request to service layer, and the service layer calls to an external client, a department client. If a 200 response is being received, it creates the employee in the DB here, which is a Dynamo DB. And once the employee is being created in the Dynamo DB, it also sends the create this request, the employee request which we have just created to the SQS also, right? So so this is just a sample service to demonstrate, right, what the sync flows look like, and it has few of the cloud services it uses along with an external client. Now the other operation it has is a get employee, where if you'll call a employee service by get employee by ID to the controller, and pass on the request to the service layer, and it tries to look for the employee ID in the DB. If the DB exists, if the employee ID exists in the DB, it will send back a response, uh, right? And if the ID employee ID does not exist, it says that does not found. So this is a sample service that we're going to demonstrate now in our code demo. So I'll open my IntelliJ. So possibly before even I'll go into the test, right? So let's just start this microservice, right? So this is where I can just starting my microservice, which is an employee service application. And you could see that it has started my employee service on 15042 port. Also, what we have done is we have a dependency to an external client called department client. This we have enabled via Wiremock server, where the client is available at a 15043 port. Also, we are using DynamoDB and the queue, right? So we are using local stack here. I can show you with my terminal. So Docker PS, I can give that command, and right. So so I've already, before this demo, right, before we started the webinar, I've just started my Docker here, uh, Docker here, which has these two services enabled. One is the DynamoDB and one is the local stack. Right. So now I'll look into the run terminal. So I'll use my Postman from here, and let's post a request to the employee. Send. Right, we could see that the employee is being created. This is the ID here, and this is the response that it brings out. So let's just copy this, right? So what we have done is we're using on this department ID. That is where we make a call to a department client, which is an external client. And let's say if the ID does not exist here, and if we send a request, it says that department ID does not exist. So this is an exception which comes from a client, external client, and it being passed on to the user that department ID does not exist, right? But we have started the mock server along with the service for the sake of the demo. And if this is 12345 is what I have instructed my mock server to return me a response here. So this is where you could see here with this right department ID, I could create a employee ID. Now with this employee ID, I can do a get employee. Right. So this is, we can see that my service is running as expected in the local. I could create an employee, and even I can do a get by employee ID operation in the local using a postman. But what happens is since we don't want to use a postman in a CI/CD pipeline, right? And we want to build more white box testing. So now let's look into how the tests are being written for this microservice to validate the similar behavior as what we just demonstrated using the postman. So I'll start with my ID test here, right? This is a features that we're talking about that uses a uh, which is nothing but tells you about the broad integration test. So if you could see, this is something that we were calling about when you write a broad integration test and you want to verify that my microservice as a whole is working as expected or not from a consumer angle. That means I want to verify the capabilities it is offering and how the consumers are going to use. This is where these broad integration tests becomes handy to test this end-to-end functionality of a given microservice. But what happens is these tests becomes complex in nature with time, with more and more capabilities added, right? And you would see, right? So now for this for this test to run end-to-end, what I need is I need a microservice to be available, running, and then I need my department client to be available, and then I need my AWS cloud services, right? DynamoDB and the SQS to be available. So even before I'll go back on how that is being done, I can show you to run the test, right? So you would see it'll take a little time. It has started the Spring Boot service by itself. Though I'm just running the test here, you could see in the logs. And now you could see that local stack. This is where we're using local test containers to initialize the local stack and the AWS DynamoDB and the SQS services along with it. So this is where it takes a time to start this application context for the entire microservice, right? And this is here now. You could see that my test have now started running. So even with a simple microservice that we have seen, it has taken around 3 seconds, 718 milliseconds, which is quite a high if you ask me, because you're going to write your uh, I would say your microservice is going to be more complex than what I'm just showing in the demo. With that, your test is also going to be complex, would become lengthier. I would not say complex, but lengthier with time. And since your application context is going to be heavy, it will take more than this to just start the application context and run the test. So with time, you would see that your tests are taking a little longer, and hence we were saying that to keep your execution times in check, and to keep these tests away from flakiness and easy maintenance, keep these broad IT integration tests minimal, and see that you only verify the critical flows which are needed to be available, to be running all the time, or the user expectations from a microservice as a whole that you are offering. Only keep those critical flows as part of these broad ITs. Maybe just to see the code, you could see here I am setting up the given employer request. And this is where I'm setting up my stub for the department ID. I see that, which is part of my test, which I see that, if pass on me this department ID request, whenever it receives a get by department ID request, pass on me this response, right? And this is where I'm actually making a call to my controller layer using a REST assured to create an employee with a request, and asserting if the status is being received as created, and storing and deslicing as part of my as create employee response TTU class. Now, this is where I do an assertions to verify if the response that my create employer is, when I, you know, uh, place a request to my when I place the post request to create the employee, the response that I received is as expected or not. This is where I'll verify it, right? And I am also verifying here as part of the queue publisher whether if I'm all, because I've said as part of the sample employee IaaS service, we're also publishing the message to the queue. So this also verifies whether the message is being posted to the queue, which contains this employee ID, which I've just created. So this is where we were mentioning, if you're using because for me to create a queue and then verify if the queue has just create a test consumer and consume the message and verifying that the message is being received, it's quite a lengthy process. So what I've done is I'm using a spy here. If I look into this, so I'm using the spy bean method here, and verifying whether if this SQS publisher has received the message as expected, which contains the employee ID or not, right? And this is where I'm making a get employee ID call, because now since my employee, I've just created an employee ID, and I should be able to call with get employee ID and see that the response is being received. And this is where we generate an expected response, and we verify if the actual for the get response is same as for the expected response. So this test actually becomes a little lengthier. And how do we initialize this is using the Spring Boot test annotation here, right? And though I'm using a defined port, but more of the test context is being kept here to keep my port allocations closer to the test here, right? So as long as my Spring uses the same application context, the server port, and the ports used for Wiremock server or for the DynamoDBs are going to remains the same. And when the application context change, when the test context changes, it's going to use a dynamic port again. So we're not going to get those errors again. Possibly just to look briefly about it. This is where we use a dynamic port allocation, right? So, but on the whole, you could see this is how you would write your broad integration test, right? Using the Spring Boot annotations. Maybe, but if you see, this uses a base broad ID, which is one of the best practices when you're writing the Spring Boot test, right? So this ensures that your now the test application context the Spring is going to initialize while running your test are going to be limited, and that keeps your resource utilization also optimal in the build pipelines. I'm just doing a quick time check here. Right. So this was about a broad integration test. Now we are talking about, since we saw, right, how with more complex microservices, your broad integration tests are also going to be lengthier. But what we are now looking at is that is where the narrow integration test plays a very critical role in devising your integration test strategy and the white box testing strategy for your microservices. So what we were talking about is writing your controller layer test or the repository layer test or the sync flow test separately, right? And now we see the differences. For example, here, what we have seen is this broad integration test has taken around 3 seconds. Now let's look into the narrow integration test. For example, in my infrastructure here, I have maybe I'll start with the controller layer test. So this is my controller layer test. So this does not require the entire microservice to be spin up as what we were seeing in the broad ID, right? All it just need the controller layer or just the web server, which receives the request and is going to deserialize and going to send a response back to the user. If the request is valid, it's going to send a right response to the user as it receives from the service layer. Or if the request is not correct or the header is missing, it's going to pass on a it'll just pass the error to the user even without calling the service layer. So that is where Spring says, if we just need to test the controller layer, why to bring up the entire application context? Keep it lower, only spin up your controller or the web server here and test every possible combinations that you want to test it. And hence, and this frees up from your broad integration test. So don't write your negative scenarios there, right? So because you are constantly, because controller layer test, you could test all the various possible combinations of positive and negative scenarios and the what exceptions a user would see in what cases. So let me just show you run this test and see how much time does these tests takes. For example, when I run these controller layer tests, right, it's still spinning up the Spring Boot service, but it's just going to spin up your controller layer. And you see these tests actually gets completed in within milliseconds. The very first test is going to take around 931 milliseconds because it was spinning up that web server also. But all the subsequent tests that you take, it's are going to be way much faster, right? So it doesn't take much time here. And how I have written these tests, we used a parameterization that here, one of the best practices when you're using JUnit, right? So write parameterization here. And what these tests does it is when a valid request is being passed, it verifies whether, am I sending the right response back to the user? And am I able to serialize and deserialize the request and responses correctly or not? So though what I'll do is I'll mock all the dependencies which I had a controller layer. So if you see my controller layer, it only has a dependency or employee service, right? So when I look at the controller ID, I'm mocking the beam here. So that means it's not going to, initialize employee service, it's going to just mock the entire employee service bean for me. And I can now illustrate here, if the employee create, if it calls the employee service, then you return me this response. And this is where, using the mock MVC, I post a request to the control relay, which is going to be an HTTP call here. And I'll verify whether the controller layer is able to deserialize properly, and serialize the serialization deserialization happens as expected or not, if the valid request is being sent. Similarly, you could also verify invalid cases, right, where you could verify if the right exceptions is being received and are we throwing the right exceptions. So you could see that we are also verifying if the error response DTO is being passed on to the user. Does it has the right error code and the right error string here? And if you want to see how the right, this is something that we have written the negative scenarios here. This is the valid request, and we say that this is a error code or the invalid message that it should be sending to the customer, to the user, let's say. So this is just a brief of how you could write an effective web controller test and make use of the JUnit parameterizations, right? Techniques to write all your positive and negative scenarios. Similarly, for get call also, I'm just written an example here where you are making a get employee ID request and see that you're returning the right response back or not. So, but if you see that these tests are quite smaller in terms, right, and are smaller when you write and very simple to write, and the execution time is also quite lower. Similarly, you could write your test for employee service. So this is just for the sync layer where the service layer receives a request and it calls an external client called department client. And if it receives a response from department client, it's going to store in the DB and push the message to the queue. So this is what my service or the sync layer was doing. So I've just written an arrow ID around my sync layer just to demonstrate an example. And you could also write if your sync layer is quite extensive in terms of business logic. So it's a good practice to write those bounded narrow IDs around the sync layer then. But if you see, these tests are quite simple to write, quite simpler in terms of lines of code and writing it also, and going to run quite fast, right? We could write it for all your all your service layers providing. And when you run these tests, you see that what we're instructing here is also for these narrow ID to Spring to only spin up the application context, which is only needed by this test, right? So somewhere I see that my tests are failing. Possibly I know the reason why, because I have not stopped my service. So because my service was also running in the background, right? So my bad, I did not do it earlier. So let me run this again now. So what we are also doing as part of this narrow ID, we're telling Spring Boot only construct the application context which is needed by this test, right? And this is where this is going to become handy. You could reuse the Spring property called lazy initialization true, which does that magic for you, right? And if you see here, the time taken by these tests is quite lesser, is in terms of millisecond. The very first time it goes to 3 seconds is that's a total time that we are looking at, right? So now let's look at the individual time here. So if you see the individual time, this is around 2 seconds. The very first test takes around 2 seconds to spin up the context alone. But once the context is being spin up, it actually runs these tests quite in just the milliseconds. So that's an optimization that Spring does it for you, that if your keys are the same, it's going to reuse the application context. And hence, so that's something that you could read more about it in the Spring documents. And possibly if the more sessions are needed, do let us know in the feedback session. We could detail in this, we can have more discussions around it. But yes, what we also using here to uh, to use the most out of the Spring optimization techniques here, and to minimize the number of application contexts we create. And even if we create, we keep our ports closer to that application context so that it does not intervenes with the others. Right. So that's more important. So this is one. And the other example that we were looking at was the repository layer test. So now what we could do, let's say, because I was using a DynamoDB repository, so I can now also write a DynamoDB test around just the repository layer to see that are my read and write operations are working fine. And these tests, if you see, are going to be quite again simpler and going to run again in the milliseconds. And just for the sake of time, I'm not going to run because I think we have exceeded the time today, right? So right. So, but what happens is, what we're trying to do is, uh, for when you're doing a white box testing here, right, and we are writing the integration test, don't try to test everything, what your microservice provides from, with spinning up the entire service, right? So what you could do is use these concepts of broad IT integration or the narrow integration test, which is there in the market for a decade now, but it's important to understand these concepts and see how you could implement when you are doing a white box testing here. And there are quite good libraries available if you're not using Spring Boot. And if you're using a Spring Boot here, Spring Boot gives you very good support, and it actually just turned around these broad IT and narrow ITs as test slices, and helps you to uh, you know control the application test context that you want to spin up, and bound your test within those boundaries. Right. So yes, with this, I think with the interest of time, I'll move on to our presentation slides again to the closing segments. Right. Do let us know if you need any, do send us a feedback for any more sessions which are needed here for the code. Just give me a second. Right. So right. So we'll move on to the next slide. What we have is around the takeaways. I'll pass on the control to Anshul. Anshul there,
Yes,
right?
absolutely. That was an amazing detailed session, Preeti. Thank you so much. Great
All right.
code there. Yes, guys, I think we are
Just
on time. So I'll just take a couple of more minutes to wrap up the
uh,
session. If you could make me the host, Preeti, I'll share.
right. Just a minute. Make host. All right.
I can. Great. All right. So guys, after seeing so much great code in Java, let's just wrap this up with some takeaways from today's session. Okay, I have not put in my, oh, yes. So the first takeaway is, as you would have seen in the code as well, test deep, test early, and test all. And all of this within the build phase. So what we are saying that with shift left, with so much investment on your white box testing, we are bringing testing a lot early in the cycle. We are making sure that every scenario is validated within the white box layer itself. Testing all possible combinations. And all of this while your application is just being built. So you have so fast tests and you have early feedback. Whenever these multiple microservices are there, which are forming your platform, do consider running contract tests ahead of the integration test, because contract tests would make sure that your interactions are intact, your schemas are adhered to, right? Only then those integration points would make sense for validation. So have contract and integration tests a good combination of them, and use the same source of mock files or interactions, which can be used in both contracts and integration testing. A defect that reaches test environment is already a delayed identification. That is one of the very important points that we want to make with this with these sessions. For a microservice, if you find a bug on a test environment, that is already late, right? Which means we have not built things in the right manner, and that is why all this effort of putting your time and investment into white box testing. So you must be able to have all these issues found as early as the local environment itself by running these static checks, units, contracts, and integration within the build phase. And hence, there should be minimum bugs that reach your test environments. Probably they are more or less about the environment, or when a lot of things are working together. Every other integration or code bug should be fixed by now. Finally, emphasize on test doubles as your technique to perform relevant, stable, and quick testing. So all your white box testing have this fundamental, which is test double. You need to make sure your microservice is being tested independently in isolation of every other component in your system. So use these test doubles as and where you require. Use one of those 4 test double that Preeti had shared. and find out and do this stable and quick testing, right? Quick, because these tests, they literally run in milliseconds and seconds, right? So have more faith on white box tests, use these test doubles, and make your microservices do shift left. That is what we had in this session. A quick look into what we are going to share in our next one. Now that white box is done and dusted, we'd be doing best practices around black box testing for microservices as well, which would quite align to our end-to-end testing and black box API level testing that most of us are aware of. Then we'll introduce the concept of defect retrospection, how that helps into finding defects early and sort of preventing defects. We'll then look at some of the quality matrices for microservices. So all these implementations that should have a value, right? The effectiveness, and we'll talk about how to make your testing effective. And then finally, some of the best engineering practices for the microservices team. So a lot of other engineering practices beyond these testing activities are required to make microservices team successful. So we'll share some of those best engineering practices, which you can go and try in your teams. So that is what we'll have in our next session. And that brings us to the end of today's session. All right. I think we're already over time. So if there's any question that comes to your mind, please keep that for the last session. We'll do that on the next Thursday, 24th of May, 7:30 p.m. All right. Thank you so much, everybody, for joining. And we'll see you soon next week. Take care. Bye, everybody. Good night.